Alright, so one other type of word problem that I will give you is, instead of me giving you the equation and you having to find the vertex, the focus, and the directrix, I will give you some information. You will need to come up with the equation of the parabola. So we're going to try a couple of these real quick just so you guys have some examples so that you'll be able to try them over the weekend on your homework. So let's say that we have a problem where a parabola where we have a vertex at -1, 3, and then we know that the focus of this particular parabola is at, let's say, -4, 3. Okay. Now the first thing that I'm going to tell you to do every single time that you see one of these is draw yourself a little picture and decide where is this thing going to open. Okay. These are not that difficult as long as you take your time and make sure that you process the information that is being given to you as opposed to just giving up right off the bat. So here's my vertex, okay, and you can draw yourself a picture here. It's real easy. If this is a -1, 3, actually let me go ahead and erase this. If this is a coordinate plane, -1, 3 is in the second quadrant, and the focus is at -4, 3. Okay, so what we see here is the focus. If the focus needs to be inside the curve, we are going to have a parabola that looks like this. Okay, now that means, because it opens to the left, that we're going to have an equation of y minus k squared equals 4p times x minus h, because anytime it's a y squared, it either has to open to the left, and it also has to, or it has to open to the right, sorry. Either to the left or to the right. Okay, now because this one opens to the left, as we learned earlier, I'm going to make a note here, p is negative. Okay, so whenever I figure out my p value, I need to make sure I make it negative because it opens to the left. Okay, now some of this information we can already fill in. Remember, the vertex is hk, so if I come over here and fill this stuff in, if I fill in y minus k, that would be y minus 3 squared equals 4p times x minus h. H is -1, so it will be x plus 1. And the only other information I need to know in order to have this entire equation is I need to figure out p. Now remember what p is. P is the distance between the vertex and the focus, and the distance between the vertex and the directrix. Now I'm not asking about the directrix on this one. All we know is information regarding the focus. So we just need to think, and then people are really bad at this, it's going to take a little bit of practice. In order to find p, we need to know what's the distance, in this case, between -1 and -4. Okay? And don't try and do any crazy absolute values, simply just use your brain here. The distance from -1 to 4 is, from -1 to -4 is 3. And remember, p is negative in this case because it opens to the left. So I'm going to make a note here. P is equal to negative, and it has a distance of 3. So when I plug in this final information, what I see is y minus 3 squared equals 4. Remember, that 4 is always going to be there, times -3 times x plus 1. And I don't have any issue with leaving your final answer like this. Or if you want to, you can go ahead and you can distribute 4 times -3, and you get -12 times x plus 1. Okay, so there would be an example of one other type of word problem. Let me show you one more that's like this. And then to finish off, we will try one graphing. So let's say that we had one where we knew the vertex was at -2, -5. And we had a directrix, that's a line, at y equals, let's say, -11. Okay? Again, if we're trying to find the equation to this, the first thing that we want to figure out is, are we working with an x squared or a y squared? So, in other words, which direction is this going to open? So if I go to -2, -5, I'm just going to throw a point over here. That means I'm somewhere here in quadrant 3. Okay, remember it goes 1, 2, 3, 4. And if the directrix is y equals, first of all, y equals is a horizontal line, and it's at -11, I would be way down here, which means if the directrix has to be outside of the curve, I'm working with a parabola here that opens up. So it is going to be an x squared. So here's what it's going to look like. X minus h squared equals 4p times y minus k. And I'm going to make a note here. In this case, p is positive because our parabola opens in the upwards direction. Okay, if I start plugging in some of this information, I'm going to have h is -2, so I'll have x plus 2 squared equals 4p. We'll go back and figure out p in a second. Y plus 5. Alright? And for the very last thing I need to figure out for p, I already decided it's positive. I need to figure out what's the distance between this vertex and this directrix. Well, if we do the math here, we are going from -5, a y value of -5, to a y value of -11, and that is a distance of 6. When I'm done here, I'm going to have x plus 2 squared equals 4 times 6 times y plus 5, and 4 times 6 is 24. So we will do our final answer looking like this. Okay? Alright, let me make sure we're all on the right track here. Okay? Alright, so we're going to finish off here with us trying one graphic one. We will practice a lot more of this on Monday. And remember, your quiz will be during your block period the following week. So we'll do a little bit more practice before that block period. We're also going to learn about circles, which are super easy for you guys. We'll learn about those on Monday and then practice some more of those before you take the quiz during your block period as well. So let's take a look at a graphing one here. Okay, now we've seen parabolas in the past, obviously, but we're going to have to do a little bit more work here on these ones because we're worrying about a focus and a directrix this time as opposed to what we were doing in the first semester. So when I look at this equation right here, because there is a y squared, I know what I'm trying to do with this is I'm trying to take this and change it into this form right here. Y minus k squared equals 4p times x minus h. Okay? Now the skill that we are going to use to make that happen is completing the square. Now you guys might not have done this for a little while, but we got really good at this first semester. So there's a reason why we were doing it, and it's all coming back into play right here. So this process in and of itself is actually pretty easy. It might look like a bunch of work to get it from here to here, but it's really not that bad. So here's what we're going to do. Okay, notice in this equation, all the y's are on one side, and everything that has an x is on the other side. So I'm going to take this, and I'm going to keep all my y's on the left side, and I'm going to move everything else over to the other side. Okay, so I'm going to have 16x plus 63 on the other side. Okay? Now, you cannot complete the square until you have a leading coefficient of 1. So the first thing I'm going to do on the left side here, because this is what I need to complete the square with, because it's the only term that is squared, is I'm going to take a 4 out of all of my y's. Y squared plus y. Now I have a leading coefficient of 1, so I'm going to put plus blank right here so I can complete the square. And then on the other side I'll have 16x plus 63, and I'm also going to put a plus blank so that I remember to add on both sides. Okay? Now, this is a little bit tricky on this one. We're going to have to use a fraction, but in order to complete the square, what I do is I take the coefficient right here, which in this case is a 1, and I'm going to cut it in half, and I'm going to square it. Please don't overthink this. Half of 1 is 1/2, and when I square 1/2, I get 1/4. Okay? Now, on a problem like this, and on all of your conic sections for this whole unit, this is essential. If you mess this up, it's going to mess up all of your work. You need to take the number that's on the outside of these parentheses and multiply it by what's inside of the parentheses before you add on the other side. Okay? If you try to just add a 1/4 right here, it's going to screw all your work up. But it's a lot nicer if we remember 4 times 1/4 is 1. So really all I'm doing here is I'm adding 1 to both sides. Okay? I'm going to rewrite the left side of this. It's going to be 4 times y plus 1/2 squared. And that's going to be equal to 16x plus 64. Okay? Alright. I'm going to keep cleaning this up here. Okay? Notice that on the right side of this equation, there is no number in front of the x inside these parentheses. So the next thing that I'm going to do is I'm going to factor something out of the right side. I can take a 16 out of 16 and 64, and when I do that, I have an x plus 4 left over. Okay? And then on the other side, I'll have 4 times y plus 1/2 squared. And then if I want to get this y plus 1/2 squared by itself, which is what I need to do, you can see up here, I'm going to divide both sides by 4. Okay? When I'm done, I'll have y plus 1/2 squared equals 4 times x plus 4. Okay? Now I'm going to make a couple notes here on this. This is a y squared, and p is positive, which means this is going to open to the right. Okay? And if we want to go one step further, if 4p is equal to this number out here, we can say 4p equals 4. So p equals 1. Okay? Which means whenever we graph this, we're going to move 1 unit inside to get to the focus and 1 unit outside to get to the directrix. Okay? So, let's make this a little bit bigger for us here. Let's see what we can do in terms of graphing. The vertex for this curve, remember hk, is going to be at -4, -1/2. So I'm going to go up here and I'm going to graph the vertex, -4, -1/2. Okay. And this is opening to the right, so p is equal to, this is opening to the right because p is squared. And if p is equal to 1, what I'm going to do is to get to the focus, I'm going to go 1 unit inside of my curve. And to get to the directrix, I'm going to go 1 unit outside of my curve, and I'm going to draw a line to signify my directrix. Okay? Now, here's the weird thing about graphing these. Everybody messes up on this. I'm going to go ahead and I'm going to label this as my vertex. Okay? And there's 2 other things we're going to find here, the focus and the directrix. We'll do that in a second. Okay? When you were graphing this, remember what I've told you, that what's special about a parabola is the distance from any point on the parabola. The distance from that point to the focus is always going to be the exact same as the distance from that point to the directrix. Okay? Now, whenever you graph these, there are only 2 other points that I want you to put on the curve, and here's how we're going to find them. Okay? In this case, the distance from the directrix to the focus is a distance of 1 plus 1, so it's a total distance of 2. So here's what we're going to do. Starting at the focus, we're going to go 2 units up, and then back to the focus, we're going to go 2 units down. That way, this distance here is 2, and this distance here is 2. This distance here is 2, and this distance here is 2. And then we're going to draw our parabola. It doesn't need to look very pretty, but I do need to see those points. Okay? And that is as close to a perfectly drawn parabola as we are going to be able to get without actually using a measuring device, is to find these 2 points right here. Okay? Now, the last thing I'm going to do is I'm going to find the focus in the directrix. Now, keep in mind, we started at our vertex at -4, -1/2, and to get to our focus, we went 1 unit inside the curve. The y value stayed the same, and if we do -4 plus 1, we get -3. Okay, so there's my focus sitting right here. Okay, and then my directrix, it's a vertical line, so it's going to be x equals. And we started at an x value of -4. We went 1 to the left to an x value of -5. Okay, so there's all the information I need when I graph these. Remember, to find these 2 points right here, what I do is I measure the distance from the directrix to the focus. Okay, in this case that was a distance of 2. So I went 2 out from the focus in one direction and 2 out in the other. That way the distance here to here is the same as the distance from here to here. Okay? You can try some of the graphing on your homework over the weekend, and we will practice it a little bit more when I see you guys again on Monday.